Hi, I am Ricky Moorhouse. I'm Cloud Architect for IBM API Connect.
And I'm Filip Verloy. I'm a field CTO at NoName Security.
Today we're going to be talking about advanced API security. So over the past year, we've seen customers reporting that the number of APIs that they've got growing over 200%. And that growth in APIs has driven a focus on API security vulnerabilities. We see here that the surveys reported that over the average number of production enterprise APIs is over 15,000. And so with 76% of organizations experiencing a security breach in the past year, and over a third reporting delays due to API security concerns. This is a big problem and something that it's API security is a superhuman problem and a vast scale. So this is something that requires machine learning for us to be able to solve it efficiently. We see several trends occurring in the market that are driving this strong growth for API management solutions. And many businesses are on an accelerated digital journey, building these new digital experiences for their customers. While each industry is different, broadly, we're seeing a drastic growth of digital transformation projects, replacing previous channels with digital ones. And this digital shift adds to this growing number of APIs and growing complexity for businesses, where integration and automation can be used to drive reductions in cost and reduce the risk of human error, helping these IT organizations manage the growing complexity of with their existing skills. As the usage of APIs grows, it clarifies the need and value in consistency for security and exposing both APIs and applications and data through APIs. With security risks and vulnerabilities from intensifying threats, API management and gateways can play an increasingly important role in how you can consistently secure and control access to your APIs and your business data across the lifecycle. IBM API Connect is an integrated API management offering available in software, SaaS, and hybrid deployment models, and provides capabilities across the key stages of the API lifecycle, from creation through managing, securing, socializing, and then deprecation and retirement as well. And API management through API Connect delivers these features while leveraging IBM's market-leading gateway technology, DataPower, which is recognized for its security and performance. IBM DataPower Gateway provides this industry-leading hardened high-security gateway appliance with support for your many different workloads, for modern workloads, traditional workloads, and hybrid combinations of all of them. And we provide a wide range of built-in and extensible policies for connectivity to a wide range of protocols and workloads, providing integration, traffic control, enforcement, and optimization. So this is a typical flow that we would see in an API scenario with DataPower. On the left-hand side, you see we've got the different things consuming the APIs. So you've got your users, many different devices, mobile applications, tablets, and they all come in through the firewall into the network. And then the DataPower API Gateway is processing those. And that provides us with this hardened appliance to make, and that makes it an excellent place to do your policy enforcement. And that would provide the security control, integration, and optimization across your business processes with a number of different things there to help you build out that. So TLS termination, handling the authentication, transformation, and protection. And then that would feed on into your backend systems throughout your organization. So whether they're applications running on the mainframe, on Kubernetes clusters, or whether they're existing services, so file storage or object storage. DataPower provides that point to access them all securely and to manage your policies and enforce them. And what we're talking about here is we can then use that policy enforcement point to add in a machine learning policy decision point. So in our integration with NoName Security, we support integrating that into the DataPower appliance so that those calls that are coming in can get processed and the decisions about which ones to serve, which ones look suspicious, can be guided by this machine learning model. So to do that, we send off the record of all the details of each API call that's going through the system off to NoName's engine. And then we get back a set of rules about how they're going to be enforced. I'll come on to a bit more detail as to how that goes in future steps. And then this gives us this augmented view of API Connect, DataPower, and the advanced API security powered by machine learning from NoName. So NoName Security extends these capabilities we've already got in the API Connect and DataPower solutions to enable organizations to provide advanced security throughout the whole life cycle. It's the joint solution that provides this comprehensive discovery of APIs and analysis of the security posture of those APIs throughout your API estate. So finding all the APIs that you've got running, whether they're the ones that are managed or pulling them in from places that you didn't necessarily know even exist. And we have all those in, we can see what data they're using, understand the posture of those APIs, anywhere that we've got misconfiguration or bad restrictions in place there. And then at runtime, we've got the ability to detect and block any API attacks or suspicious activity by this real-time analysis that's powered by the machine learning. And to do this with API Connect and NoName, it's as simple as just dropping in a policy at the API assembly step. So you can see here, we've got an example of the API Connect user interface. We've got a simple API, and there we've got the policy just dragged in and configured to talk to the NoName engine. That gives us that enforcement point. Now, the full picture of how that works with a high-level architecture, similar to the diagram I showed before, we've got the API consumers on the left-hand side coming in through the firewall. And then we've got API Manager at the top, where we're managing all our API definitions, and then these get published alongside the policy to the DataPower Gateway. So we've got the NoName Advanced Security API Security Policy sitting there on the DataPower alongside the APIs. When the call comes in, our out-of-band analytics engine will send the data through for every API call. So you've got all the details of what's going on. To get the best out of this, you'd want to send the full data, the response and request, and they get logged to our analytics engine, but also sent off to the NoName Security engine to form that basis of learning in order to set your rules around and understand your estate. Then those protection rules are what are pulled back to the DataPower for runtime enforcement to catch anything that's going on in real time and to do any blocking that's necessary. So at that point, I'm going to hand over to Filip to show us a bit more about how this looks and tell us more from the NoName side.
Yep, thanks very much, Ricky. So the first thing I sort of wanted to touch upon is we, from a NoName perspective, sit out of band as well. So what we do is we ingest this information that we're getting from API Connect or DataPower or both, depending on your setup. And then initially what we sort of focus on is building a comprehensive inventory of the APIs that you have. And this could be APIs that are managed through API Connect. It could also be APIs coming from different sources, potentially unmanaged APIs, or whilst you're planning a migration, for example, into API Connect. The idea is to give you this extensive end-to-end inventory so you know what to focus on from a security perspective from an API point of view. So the idea is we'll take that as input and then we'll provide our context around it so you can better understand what is going on from a security perspective with those APIs, meaning we have a specific focus on providing sort of that additional security context, things like where is a specific consumer making an API call onto, what type of method is this user using, for example. So these things provide us with some context. An example would be, let's say you're doing a GET request to user acceptance testing.api.com versus a GET request to production .api.com, or to /admin versus /users. All of these things provide additional hints or additional context to sort of glean what is going on. So the idea would be to provide you with a lot of additional input or context around each individual API endpoint, so we can start looking at the API from a sort of security lens or security perspective. Now, because we are an out-of-band solution and we take our information out of API Connect or DataPower in terms of enforcement, as Ricky mentioned, we feed back into that DataPower API Gateway to block on our behalf after we've made a detection. So the idea would be, because we are not in the path of the API call itself, we do not have the capability at that particular point to, for example, block an attacker. So if we decide that the, let's say, transactional information we've seen indicates an attack or a potential attack towards an endpoint, then we'll take that information and feed that back, creating a rule on the DataPower Gateway. So automatic blocking can occur, and your APIs are protected going forward. We provide a number of frameworks as well to which to sort of look at your overall API security environment. Two of the frameworks that are sort of out of the box in the system are the OWASP API Top 10, both 2019 and the new 2023 list. So the idea would be that we want to give you this quick high-level overview to have a classification based on our internal severity scoring, but also through that external framework lens, with the goal of getting all of the API stakeholders somewhat on the same page when talking about API security. So if you think about a large API environment, there's plenty of stakeholders with all kinds of different tooling that sort of needs to come together and to some extent speak the same language to really implement these security controls. So if there's API program owners and then API designers and developers, but there's also application security personnel, network security people, maybe even a mobile team and so on. So they all have their own tooling and their own sort of way of thinking through API security. So a framework like the OWASP allows them to sort of come together and look at things from a similar perspective. Back to Ricky's point of sending sort of the full payload, giving us that additional context, an additional value add there is that we can also look at that data from a data regulatory perspective, meaning if you're in a financial services environment, for example, and you're maybe interested in like PCI DSS type of data that you want to flag specifically or handle in a specific way, have specific rule sets around where that data can flow and who can access it. It's easy to create data policies from a NoName perspective around these payloads, both from an API request and a response perspective, and then push down those policies, ultimately resulting in potentially a blocking rule again on the DataPower Gateway system. In terms of deployment, NoName can be deployed or consumed as a SaaS service, or we can be deployed and consumed in an on-premises / hybrid cloud environment, whereby the entire software stack, including our machine learning capabilities, would run in the customer's own premises, meaning no data is ever externalized to operationalize this API security add-on for IBM. So everything is analyzed and crunched locally in your own data center. Your own data center could also be a cloud environment running on under your own cloud account, for example. Additional point I wanted to raise here is that we work on the basis of this mirrored traffic coming from API Connect or DataPower. So we are not an additional bump in the wire. There's no additional latency introduced in analyzing this data from a security perspective. Just like API Connect is sort of out of band, we take that analytical information and then apply our ML models to that. So there's no additional slowdown or any user experience-based impact that you can see when adding on this additional layer of API security. So let me switch gears a little bit and jump into a demo. So this is our main UI where you're dropped into. The first thing that you would need to do is to integrate traffic sources, as we call them. So the idea would be through integrations. You can see we have a number of different integrations, but we start with traffic sources. The idea would be you add your IBM API Connect connectivity to our system, or DataPower, or both. And then once those connections are made, traffic will start to flow, and we will automatically build this inventory. So in this case, we've discovered 120 APIs across 35 different hosts, and we will perform a high level of classification immediately based on that traffic. So this could be things like what is actually in the payload. So are we talking about things like credit card numbers, names, IP addresses, etc.? What API types are you running in your environment? RESTful APIs, SOAP, XML, GraphQL, etc. What type of authentication are you enforcing or supporting on those endpoints? And can we give you some high-level security classification in terms of a potential IDOR, like a BOLA type situation, or APIs that are internet-facing, or zombie APIs that haven't been used for a number of days? So that is part of that high-level classification. Once we have that, we go quite a bit deeper as well. So for each and every endpoint, we'll show you the host of that endpoint, the complete path. And for every different method, so every different interaction method towards that endpoint, we'll do a different security classification as well, because a different method may result in a different issue that we're seeing from an OWASP classification perspective, for example. So what you see here are things like the issues that we've detected for that specific endpoint, what type of data is being exchanged across this API, what type of data tags are available here. If you want to open one up specifically, we'll give you additional detail as well. So is this API internet facing? If so, through HTTP, HTTPS? Is it internet accessed? Yes or no? What type of API is it? What type of authentication? JOT tokens in this case. How many people are consuming your API? Is it relevant for PCI data or PCI or PII data classification, for example? What is the backend technology stack that's powering this API? So all of these things are relevant in terms of security. If you have tagged an owner to a specific endpoint, we can pull that in as well. What we'll do here then is, if we have to start a remediation action because we have detected a misconfiguration, for example, we can automatically assign a ticket in Jira, for example, to the correct owner. So that can be automated in a much deeper sense, depending on the amount of information we have up front for those APIs. We also see the API spec as built from the network traffic that we are detecting, meaning if we come to the conclusion that there's a difference between the API specification that you've uploaded and the API specification that we've detected on the network, we can flag you for that as well. So you can easily go in and then update that information if need be. Now, there's a whole lot of information on this system, which will potentially make it a bit tricky to figure out what is relevant for your specific use case. So we've created this thing called a query catalog, whereby if you have a specific use case, or for example, you're in the GRC team or something like that, and you want to look at compliance-specific APIs, then you can say, okay, show me all of the APIs that manage sensitive data, and the query catalog will pull out those APIs specifically, so you can triage a bit more and focus on that. Of course, you can build your own queries as well from that system, and then tune it to your specific use cases. The system also detects if there's any changes on the endpoint. So if new fields get added, new headers get detected, we'll show you that in this view. And we can also notify you if new APIs show up. Meaning, if we detect something new, we can kick off a workflow whereby we will, for example, send you a Slack message saying, well, nobody kicked off a workflow to create a new endpoint, but a new endpoint appeared anyway on the network. So maybe potentially something is happening here that you should be aware of. We'll give you that information so you can easily jump back into the system and figure out what is going on. All right. The other thing that we spoke about were data types. So we have a large set of built-in data types that are available out of the box or predefined, as we call them. So you can look for things like social security numbers, credit card numbers, specific country-based telephone numbers, and so on. But of course, you can create your own data types as well on the basis of a regular expression. Additionally, what we will do or give you the option to do is to obfuscate the data, meaning that if we detect something and we want to keep a record of that data as evidence for your SOC team, for example, we will not put in the data in clear text in the evidence, but instead we will obfuscate that data. So we'll say we've detected a credit card number, but the actual credit card number won't be part of that evidence payload. So if you have a data type set, you can build a data policy on the basis of that. So for example, we can say we want to look for specific PII relevant data, and then the data policy can kick off an additional workflow to bring you up to speed that you have to look at something or to implement a blocking rule or a security policy, something like that. Those policies are built on the basis of workflows. So we have workflow integrations as well. So there's a number of out-of-the-box workflow systems, things like QRadar, for example, that we can leverage to take that remediation step out of the NoName platform and bring it into your existing processes to remediate anything that we've detected. From the prevention side, then, once we've detected an attacker or a misconfiguration, typically an attacker will give you that ability to allow DataPower or API Connect to remove that attacker from the equation, so any subsequent attack would fail. So the inventory is one piece. I'll give you a quick a bit of information here. We also show you the consumers, so who's actually consuming those APIs, where are they coming from? Are they, predominantly mobile users, et cetera, But there's also an infrastructure component associated with this, meaning if you're hosting your APIs on a backend system, we saw like an Nginx example before. Well, that Nginx is running on something, could be a cloud VM or, a Lambda function, whatever you happen to be using, there's infrastructure associated with it. And that infrastructure can be vulnerable as well. So let's say you have DataPower in front of your API, you're managing it using API Connect, you're monitoring it using NoName, so everything is fine. But let's say that VM that's powering that API has, SSH open, has no OS patches for 6 to 9 months, something like that. So that system is still vulnerable. So we have to connect those two pieces together to give you a fuller picture of how vulnerable potentially those APIs are. So that's why we have this infrastructure integration here, where you can easily see, well, if I'm running a system, from a VM, for example, here, is there anything wrong with that VM that I should be aware about, and what do I need to do to patch that VM and bring an infrastructure in line with my security policies? So the more important piece is the security aspect. So once we have that full inventory, the monitoring sort of happens automatically. But then if we detect things, you sort of have to go in and figure out how to remediate these security issues. As mentioned before, we can do that on the basis of the OWASP frameworks. We can also just show you our posture and runtime findings or incidents. So from a findings perspective, we'll focus on misconfigurations in your environment that you can then easily fix. So for example, here we have a bunch of APIs that don't match the API specification as mentioned before. So you could open those up and then take remediation action to bring those in line. For example, we have things like an internet-facing API exposing sensitive data, but there was no authentication set. So these things give you the hints needed to then go in and implement any remediation if needed. Now, posture or misconfiguration is one thing. Where the machine learning sort of steps in is in the runtime security aspect. So with runtime, we have incidents on the one side. So these are security issues that we've detected based on real-time API traffic. And then there's also the attacker's view. So the attackers takes or changes the lens of these issues through an attacker, through a single attacker who could be responsible for many different issues. So if we sort of start by looking at the incidents first, so for example, here we have Ebola issue in the environment. So the idea would be our machine learning engine looks at how this endpoint is being used. It builds a historical baseline based on how expected behavior looks like. So we've sort of looked at how are most people interacting with this API. That allows us to build a baseline of normal behavior. Then every subsequent call that comes to that API can be compared with that baseline. And then if we see a deviation or an outlier, we can easily say, oh, this is a potential issue, and this is a remediation that we propose for you to implement and go ahead. As mentioned, there's also this view attacker page. So if you want to look at it from the lens of the attacker, we'll show you where this attacker is coming from, the evidence. So this is that Ebola attack that I mentioned before. So what you see here is 21 transactions against this endpoint. The idea is you have a user here using a JOT token to authorize himself, calling an endpoint. So you can already see that this JOT token payload doesn't match the user GUID that is calling. But if you then sort of traverse the calls, you can see that it's using the same JOT token. The GUID of this endpoint keeps changing. He keeps getting a 200 response, meaning a successful return. You can see that the data does not belong to the specific user. What you can also see is that credit card information is coming back. In the evidence view here, though, we have obfuscated that data. But in any case, you can still see that this attack is sort of successful. So here you can clearly figure out on the basis of this timeline what the attack looks like, and this is clearly not normal or expected behavior. So what you can then do is you can take this attacker and block him. So if we block this specific attacker on the basis of the identifier, which in this case would be the JOT token, we will ask DataPower to remove this user from our environment here. So a subsequent attack would not be successful anymore. So that is the sort of security classification. We also have our internal security severity classification, meaning we have critical issues that we can flag to help you sort of triage and help you focus on what is the most important from the findings here. In this environment, obviously, we have a lot of issues going on, but in a typical environment, that would look more manageable. But we will guide you to what is most important, so you can sort of focus on the most critical and then the high severity issues in your environment before sort of moving on those misconfigurations and so on. Now, next to this sort of real-time view, I just wanted to point out we also have a reporting capability as part of the environment. So you can build your own report depending on what you find most important. And then we can send this sort of high-level report. So if you only want the exact summary, for example, we can export that to a PDF, send it in to the manager of the SOC, for example. So follow-up is then possible. One additional thing I'll point out as well is the capability to upload your API specs. So I mentioned before that you can upload the specification of your API, and we can then analyze that versus the traffic. But we can also perform some linting operations on that if you want us to do that. But that's part of the environment as well. And we also have a full-blown management API. So the idea would be what I've shown you in the demo through ClickOps is anything that is clickable here, all of the functionality is also available as an API endpoint. So if you want to automate this entire thing, integrate it with external systems and so on, that's easily possible through our management API as well. So I know this was a very high-level overview of the system. We can easily spend half a day going through the entire functionality and the entire environment. But as an introduction, I'll sort of want to leave it there. So the last thing I wanted to point out is if you want to learn a bit more, you can go to ibm.biz/API security, or if you want to learn more about the partnership, you can go to nonamesecurity.com/IBM, where we'll sort of show you the advanced security capabilities that we bring to the IBM side, and then the IBM capabilities and how they sort of match and integrate nicely with what we are doing. So with that, I wanted to thank you for attending our session. Thanks very much.